All right, welcome back. We are on day 5 of our ACT Prep Unit 4, which is the intermediate algebra topics. Today we're going to start talking about solving quadratic equations. So quadratic equations can be written in this standard form, ax squared plus bx plus c equals 0. Since the largest exponent of x is 2, the equation can have at most 2 solutions, also called roots, also called zeros. It may be difficult to solve a quadratic equation by factoring, which is the technique we've used previously. You can always use the quadratic formula to solve quadratic equations. It works all the time. Factoring doesn't always work. And the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. The a, the b, and the c come from your coefficients of your quadratic equation. A is whatever touches the second degree x, b is whatever touches the first degree x, and c is your constant. Once you name a, b, and c, b goes here and here. I color code it because it kind of helps you to picture it. Your a goes here and here, and then your c is on the end. Okay, so see your 2 b's in red, your 2 a's in green, and your c on the end in purple. Okay, so let's solve this. Well, the first thing that's wrong is this is not in standard form. Standard form says it has to be ax squared plus bx plus c equals 0. So my first job is to get 0 on one side. So I'm going to minus 3x, which gives me 4x squared minus 3x minus 2 equals 0. So now I know that a is 4. I know that b is negative 3, and I know that c is negative 2. So all I have to do is plug them in. So I put b in the first two, I put a in the next one in the bottom, and I put c on the end. And in my experience, the biggest thing people screw up is this underneath here. They try and type all this at once, which you can do, but I don't recommend it. I mean, half the time when I type it all in at once, I screw up and get the wrong answer. So what I do is I type this piece, just this piece, exactly the way I wrote it, parentheses and all, in the calculator, and I do this and this, so that gives me x equals 3 plus or minus the square root of 41 all over 8. Okay, and then what you're going to do, depending on what your answers are, sometimes they'll leave it in simplest radical form, which you should try and break your radical down, but 41 is prime, so I can't break 41 down. There's no perfect square in it. So in simplest radical form, those would be my 2 answers. If they want you to go decimal, then you type it in. You'd have to type 3 plus the square root of 41, and if you're going to do it all at once, divided by 8, enter, and then 3 minus the square root of 41 in parentheses divided by 8, enter, and you'll get your other 2 answers. This one is 1.18, and this one is negative 0.43. Okay? Alright. Oh, I typed it in for you. Okay? And I rounded to the nearest hundredth. Alright. You try this one, hit pause, come back when you're ready. Sorry about the answer right there. Try not to look. Alright, and hopefully you got 30. They want the sum of a, b, and c. So we're not even actually solving this. All we have to do is figure out what a, b, and c are and add them up. Well, to see a, b, and c, you've got to be in quadratic form, which means 0 has to be on one side. So I'm going to move 13x over, and I'm going to move the positive 6 over, which gives me 0 on this side. None of these are like terms, so just drop them all in quadratic order, which is 23x squared plus 13x minus 6, which means a is 23, b is 13, and c is negative 6. So if I add all those up, I get 30. Okay? Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got negative 5 and 7. Alright, here's my equation. Alright, which means my b is negative 2. So I put a negative 2 here and a negative 2 here. My a is 1, so I put 1 here and 1 here. And my c is negative 35. And again, so I don't screw this up, I type in underneath first. So that gives me x equals 2, a negative times a negative is a positive, plus or minus the square root of 144 all over 2. Then this happens to be perfect. That square root of 144 is 12, so I have x equals 2 plus 12 over 2. And my second solution is 2 minus 12 over 2. This is 12, and you got to do plus or minus. So if I do the 2 plus 12, I'm trying to find the colors. That would be 14 over 2, which gives me x equals 7. 2 minus 12 would be negative 10 over 2, which gives me x equals negative 5. And those are my two solutions. Okay? So some practice problems. They want me to write the quadratic formula, which you should have memorized. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 2 wants me to just identify a, b, and c, which I cannot do until this is in standard form, which means I need 0 on one side. So I'm going to add 8x, which gives me 0 on one side, which is what I want. Now these you need to put in quadratic order, which means the second degree term first, and its sign, it's negative. Then my positive 8x, and no sign in front of 3 means it's positive 3, which means a is negative 2, b is 8, and c is 3. Okay? Alright, and then they're just going to make me practice a whole bunch of quadratic formula. Okay, we're in standard form. So, we're in standard form. So b is negative 3. A is 1. And c is negative 4. And if I type in underneath the radical, 3 squared, negative 3 squared minus 4 times 1 times negative 4 is 25. So I have x equals 3 plus or minus the square root of 25 all over 2, which means this is 5 plus or minus, so I have x equals 3 plus 5 over 2, and I have x equals 3 minus 5 over 2. Simplifying those, that's 8 divided by 2, x equals 4. That's negative 2 divided by 2, x equals negative 1. And there's my two solutions. Number 4 is not in standard form, so to get 0 over here, I'm going to minus 4x, which gives me 5x squared minus 4x minus 2 equals 0, which now tells me that b is negative 4, so that goes here and here. I now know that a is 5, so that goes here and here. And I now know that c is negative 2, which goes on the end. Typing in underneath the radical, I get 56. So I have x equals positive 4 plus or minus the square root of 56 all over 10. Now, again, depending on what the answers are. If they want radical answers, that probably isn't going to be it either, because 56 has a perfect square in it. So if I break 56 down, by 2 is 28, by 2 is 14, by 2 is 7. I got a perfect square of 2 in there, and then these have to go back in. So square root of 56 is 2 square roots of 14. Which means in radical form, my solutions are 4 plus or minus 2 square roots of 14 all over 10, which I can reduce by 2. 2 goes into 4 twice, 2 goes into 2 once, 2 goes into 10 5. So in radical form, my answers are x equals 2 plus or minus the square root of 14 all over 5. And that would be in radical form. Now, if they want decimal form, then you would have to type in, let's see if I did it. I did. You'd have to type in parentheses 2 plus the square root of 14 divided by 5, which gives me 1.15 if I round to the nearest hundredth. And then parentheses 2 minus the square root of 14 divided by 5, which gives me x equals negative 0.35 if I round to the nearest hundredth. Okay? All right, number 5, again, this is not in standard form. You could move the 5x and the 2 over here, but I'm going to move that over because it's less to move. So I'm going to add 2x squared, which gives me 0 over there. In order on the other side would be 2x squared plus 5x plus 2 equals 0, which now tells me that b is positive 5 and a is positive 2 and c is positive 2. And I type in what's underneath so I don't screw it up, and I get 9. So my solutions are x equals negative 5 plus or minus the square root of 9 all over 4. Simplify, the square root of 9 is 3. So my two solutions, I'm going to have x equals negative 5 plus 3 over 4. And my second is going to be negative 5 minus 3 over 4. Simplifying those, negative 5 plus 3 is negative 2 divided by 4 is negative 1/2. Negative 5 minus 3 is negative 8 divided by 4 is negative 2. And there's my two solutions. Okay. Alright, so if we try this one, again, we're not in standard form, so I'm going to minus x and minus 6 to get 0 on this side. Drop these in quadratic order and you get x squared minus x minus 6 equals 0, which tells me that b is negative 1, that a is 1, and that c is negative 6. Typing in underneath the radical, I get 25. So I have x equals positive 1 plus or minus the square root of 25 all over 2. Simplifying, the square root of 25 is 5. So my two solutions, I have 1 plus 5 divided by 2, and I have 1 minus 5 divided by 2. Simplifying those, 1 plus 5 is 6, divided by 2 is 3. 1 minus 5 is negative 4, divided by 2 is negative 2. And those are my solutions. Okay. Number 7, I've got to get it in standard form, so I'm going to add x squared, gives me 0 over here. Drop them in quadratic order, x squared plus 3x minus 4, which tells me that b is positive 3, that a is positive 1, and that c is negative 4. Alright, typing in just what's under the radical, I get 25. So my solutions are negative 3 plus or minus the square root of 25 all over 2. The square root of 25 is 5, so my two solutions are negative 3 plus 5 divided by 2, and x equals negative 3 minus 5 divided by 2. Simplifying those, negative 3 plus 5 is 2, 2 divided by 2 is 1. Negative 3 minus 5 is negative 8, divided by 2 is negative 4. Those are my two solutions. Alrighty. Number 8, we're in standard form, so I can see that b is negative 5, that a is 2, and that c is negative 3. Typing just what's under the radical, I get 49. So my solutions are x equals positive 5 plus or minus the square root of 49 all over 4. The square root of 49 is 7, so my two solutions are x equals 5 plus 7 over 4. And my second one is 5 minus 7 over 4. Simplifying those, 5 plus 7 is 12, divided by 4 is 3. 5 minus 7 is negative 2, divided by 4 is negative 1/2. Okay. Number 9, I've got to get it in standard form, which means I want 0 over here, so I'm going to minus 56, which gives me 0. Quadratic order would be x squared plus x minus 56 equals 0, which now tells me that b is positive 1, that a is positive 1, and c is negative 56. Typing just what's under the radical in, I get 225. So that gives me x equals negative 1 plus or minus the square root of 225 all over 2. The square root of 225 is 15. So my two solutions are negative 1 plus 15 over 2, and x equals negative 1 minus 15 all over 2. Simplifying those, negative 1 plus 15 is 14, divided by 2 is negative 7. Negative 1 minus 15 is negative 16, divided by 2 is negative 8. Okay. Alright, number 10 is not in standard form, so we're going to minus 7x, which gives me 0 on one side. Quadratic order would be x squared minus 7x minus 18, which tells me that b is negative 7, that a is positive 1, and that c is negative 18. Typing in just what's under the radical, we get 121. So that gives me x equals a positive 7 plus or minus the square root of 121 all over 2. The square root of 121 is 11, so my two solutions are 7 plus 11 over 2 and 7 minus 11 over 2. 7 plus 11 is 18, divided by 2 is 9. 7 minus 11 is negative 4, divided by 2 is negative 2. Okay, number 11 is in standard form, so that tells me that b is positive 9, that a is 4, and that c is 2. Typing just what's under the radical, I get 49. So I have x equals negative 9 plus or minus the square root of 49 all over 8. The square root of 49 is 7, so my two solutions are x equals negative 9 plus 7 over 8, and x equals negative 9 minus 7 over 8. Simplifying those, negative 9 plus 7 is negative 2, divided by 8 is negative 1/4. Negative 9 minus 7 is negative 16, divided by 8 would be negative 2. Okay? Alright, number 12 is not in standard form, so I'm going to add 6x, that gives me 0 over there, 2x squared plus 6x plus 4, which tells me that b is 6, that a is 2, and c is 4. Typing just what's underneath, 6 squared minus 4 times 2 times 4 is 4. So I have x equals negative 6 plus or minus the square root of 4 all over 4. The square root of 4 is 2, so my two solutions are x equals negative 6 plus 2 over 4, and x equals negative 6 minus 2 over 4. Simplifying those, negative 6 plus 2 is negative 4, divided by 4 is negative 1. Negative 6 minus 2 is negative 8, divided by 4 is negative 2. Okay. Alright, on 13 we're not in standard form, so I'm going to add 6. Gives me 0. In quadratic order would be x squared minus 5x plus 6, which tells me that b is negative 5, that a is 1. Oops, didn't change color. A is 1. A is 1. And C is positive 6. Typing just what's under the radical, I get 1. So I have x equals positive 5 plus or minus the square root of 1 all over 2. The square root of 1 is 1. So my two solutions are 5 plus 1 over 2 and 5 minus 1 over 2. 5 plus 1 is 6, divided by 2 is 3. 5 minus 1 is 4, divided by 2 is 2. And those will be my solutions. Okay. Alright, on 14, it's in standard form, which tells me that b is negative 4, that a is positive 4, and that c is negative 15. Typing just what's under the radical, I get 256. So I have x equals a positive 4 plus or minus the square root of 256 all over 8. The square root of 256 is 16. So my two solutions are going to be x equals 4 plus 16 over 8 and x equals 4 minus 16 over 8. Excuse me. Simplifying those, 4 plus 16 is 20 over 8, which 8 doesn't go into 20 evenly, but I can reduce by 4, which would be 5 halves. 4 minus 16 is negative 12 over 8. Again, I can't divide evenly, but I can reduce by 4, which would be negative 3 halves. And those are my two solutions. Alright, 15 is not in quadratic form. Since I'm going this way this time, since I only have to move one thing, so I'm going to minus 26x, minus 26x. I get 0 equals negative 3x squared minus 26x plus 9. Which tells me that b is negative 26, that a is negative 3, and c is positive 9. Typing just what's under the radical, I get 784. So I have x equals positive 26 plus or minus the square root of 784 all over negative 6. The square root of 784 is 28. So my two solutions are x equals 26 plus 28 over negative 6. Excuse me, and x equals 26 minus 28 over negative 6. So this would give me, simplifying these, oh, I went backwards. Okay, this would be x equals 54 divided by negative 6, which would give me negative 9. And this would give me x equals negative 2 over negative 6, which would give me positive 1/3. Okay. 16 is in standard form, which tells me that b is 25, that a is 4, and that c is negative 21. Typing just what's under the radical, I get 961. So I have x equals negative 25 plus or minus the square root of 961 all over 8. The square root of 961 is 31. So my two solutions, I'm going to have x equals negative 25 plus 31 over 8, and x equals negative 25 minus 31 over 8. Doing the math, x equals negative 25 plus 31 is going to be 6 over 8, which reduces down to 3/4. Negative 25 minus 31 is negative 56 over 8, which gives me negative 7. And those are my two solutions. Okay, on this one, we're not in quadratic form. And I actually went this way. I don't know why. It would have been easier the other way. But so I'm going to minus 9x minus 15. There's my 0 on one side. Quadratic order would be 6x squared minus 9x minus 15, which tells me that b is negative 9, that a is positive 6, and that c is negative 15. Typing just what's under the radical, I get 441. So x equals positive 9 plus or minus the square root of 441 all over 12. The square root of 441 is 21. So I have x equals 9 plus 21 over 12, and x equals 9 minus 21 over 12. Well, 9 plus 21 over 12 would be 30 over 12, which reduces down to 5/2. If I divide both by 6, sorry, I didn't change colors, did I? So you got x equals 5/2. This one, 9 minus 21, is going to be negative 12 divided by 12 is negative 1. And there's my two solutions. Alright, 18. Mr. Wilson's rectangular garden has an area of 27 square feet. If the length of his garden is 3 times its width, which I don't know, so let's call it x, then its width is x, what are the dimensions of the garden? Well, what this says is 3x times x, length times width, has to equal the area. So this gives me 3x squared equals 27. This is not in quadratic form, so I'm going to minus 27 minus 27. I get 3x squared minus 27 equals 0, which means a is 3. 27, that has to be c, because it, oh no, I don't have an x to the first, so what's b? Well, if you don't have a b, it's 0. Okay, I mean, I could actually solve this one faster just doing algebra, or not, well, yeah, using algebra instead of quadratic formula. But just so you can see, when you have a term missing, just whatever term's missing, your value of that coefficient is 0. So if I plug in my b, which is 0 here and here, my a is 3 here and here, and my c is negative 27. If I type just what's under the radical, I get 324. So I have x equals 0 plus or minus the square root of 324 all over 6. Well, the square root of 324 is 18. So my two answers are positive 18 over 6, because 0 plus 18, and 0 minus 18 would be negative 18 over 6. So simplifying those, x equals 3 and x equals negative 3. Okay? If it would have been me though, once I got this, there's no x to the first, so just isolate its root. So divide by 3. I got x squared equals 9. Square root, x equals plus or minus 3. You get the same thing. But just to show you that quadratic works even if you're missing a term. Alright, another one. It says the area of a rectangular pool is 180 feet. if the pool is 3 feet longer than it is wide, so the length, whatever it is wide, let's call it x, the length is 3 feet longer. That's not 3 times longer, 3 feet longer, so that's just adding. So now I can say that x times 3 plus x has to equal 180. If I distribute, I get 3x plus x squared equals 180. Put it in standard form, I'm going to minus 180, and I get x squared plus 3x minus 180 equals 0, which tells me that b is 3, that a is 1, and that c is negative 180. Typing in just what's under the radical, I get 729. So I have x equals negative 3 plus or minus the square root of 729 all over 2. The square root of 729 is 27. So I have x equals negative 3 plus 27 over 2. And x equals negative 3 minus 27 over 2. Solving this one, I get x equals 24 over 2, which gives me x equals 12. Solving this one, I get x equals negative 30 over 2, which gives me x equals negative 15. Now, we're looking for, I didn't answer the last question. We're looking for the dimensions of the pool. So what we're finding is the width. Is there any way a width can be negative? No. So it's not wrong mathematically, but in the context of this problem, it's extraneous because you can't have a negative length. So my width must be 12, and to find the length I add 3 to it, so 3 plus 12, my length would be 15 feet. We didn't answer the last one, did we? Yeah, this one, it says, what are the dimensions of the garden? I didn't actually find out. Again, we're talking about dimensions of a garden. So a negative distance makes no sense. We would call that extraneous, which means if my length, or my width, that's what I called x, so width is 3, then times that by 3, and my length would be 9 feet. Okay, Chan is framing an 8 by 10 inch picture. So this is 8, this is 10. And the area of the picture and the frame, so he's got a frame around this, is 143. So I need this length times this width to equal 143. Well, that's not 8 by 10 anymore. They added on a length, which I don't know. They added on x here, and they added on x here. That makes this distance not just 8 anymore, but 8 plus 2x. Likewise, on the width, this isn't 10 anymore. They added on x here, and they added on x here, so this length is now 10 plus 2x. So my area equation is 8 plus 2x times 10 plus 2x has to equal 143. Okay? Well, again, I can't do anything until I get 0 on one side. So I'm going to have to FOIL this out. That's going to be 80. That's going to be 16x. That's going to be 20x. And that's going to be 4x squared. So now I'm going to combine like terms. So I'm going to do a couple things at once. I'm going to combine these. I'm going to get 0 on one side. And then this all mess, I'm going to put it in quadratic order, which would be 4x squared first. Then the linears, which is going to give me plus 36x. And then my constant, 80 minus 143, is negative 63. Which tells me that b is 36, a is 4, and c is negative 63. Okay, just typing in what's underneath the radical, I get 2304. So x equals negative 36 plus or minus the square root 2304 all over 8. So x equals negative 36 plus or minus 48. Sorry, I forgot to change colors. The square root of 2304 is 48. So I have x equals negative 36 plus 48 over 8, and x equals negative 36 minus 48 over 8. Okay, this one gives me 12 over 8, which reduces down to 3/2, which again, we're talking about a length, so that's 1.5 inches. That makes sense. This one is going to give me a negative 84 over 8, which I don't care what it reduces down. You're talking about the length of that frame, which can't be negative. So it's got to be 1.5 inches wide. Alright, so you try this one, hit pause, come back when you're ready. Hopefully you got 112. It says, what is the product of A, B, and C? So I don't even need the quadratic formula. They're not telling me to solve it. They just want me to multiply the coefficients, which you can't see properly until 0's on one side. So add 14x, and I get 4x squared plus 14x plus 2 equals 0. So now they want A, which is 4, times B, which is 14, times C, which is 2, and that gives me 112. Okay, try this one, hit pause, come back when you're ready. And hopefully you got negative 3.5 and negative 2. Alright, we're not in quadratic form, so I'm going to add 44x. And I'm going to add 56. That gives me 0 on one side, and in quadratic order I get 8x squared plus 44x plus 56 equals 0, which now tells me that B is 44, that A is 8, and that C is 56. Typing just what's underneath, I get 144. So I have x equals negative 44 plus or minus the square root of 144 all over 16. The square root of 144 is 12. So I have x equals negative 44 plus 12 over 16. And x equals negative 44 minus 12 over 16. So this one gives me x equals negative 32 over 16, which gives me negative 2. This one, x equals negative 56 over 16, which 16 isn't going evenly, but I can reduce it, and I get negative 7/2. 8 goes into both of them. And negative 7/2 is negative 3.5. Alright, try this one, hit pause, come back when you're ready. And hopefully you got negative 6 and negative 2. We're in quadratic formula, which tells me that B is 16, that A is 2, and that C is 24. Typing just what's under the radical, I get 64. So I have x equals negative 16 plus or minus the square root of 64 all over 4. The square root of 64 is 8, so my two solutions are x equals negative 16 plus 8 over 4, and x equals negative 16 minus 8 over 4. Simplifying these, negative 16 plus 8 is negative 8, divided by 4 is negative 2. Negative 16 minus 8 is negative 24, divided by 4 is negative 6. Okay. Alright, hit pause, come back when you're ready. And hopefully you got 0. Alright, so we've got this problem here. They want the sum of the solutions to this quadratic. Well, it's in quadratic form, which tells me b is 0, because there is no b term, there's no x term. A is 21, and C is negative 189. Typing just what's under the radical, I don't know why I did that. Oh, I solved it on algebra instead of doing the goofball. What the heck? I don't know why. I'm not gonna be able to figure out what that is. But sorry, I don't have my calculator with me. I didn't solve a quadratic. I did it algebraic because there's no first degree x. To me, it's more work to do quadratic formula, even though it says to. But if I add 189, again, when there's no first degree x, you can just isolate and kill. So I'd have 21x squared equals 189. Divide by 21, x squared equals 9, which is why I did that. Square root, and x equals plus or minus 3. So my solutions are x equals positive 3 and x equals negative 3. And it says add them up. Well, positive 3 and a negative 3 add up to 0. Alright, try this one. Hit pause. Come back when you're ready. Hopefully you got A. Alright, we are not in quadratic form, so I'm going to add 6x squared, which gives me 0 over here. And my function is 6x squared minus 29x minus 22 equals 0, which now tells me that b is negative 29, that a is 6, and that c is negative 22. Typing in just what's under the radical, I get 1369. So I have x equals 29 plus or minus the square root of 1369 all over 12. The square root of 1369 is 37, so x equals 29 plus 37 over 12. And x equals 29 minus 37 over 12. Well, 29 plus 37 is, I don't know, x equals, I've already simplified it for whatever reason. Oh, I think I typed it in. Oops. I don't know what I typed. Oh, okay, so there we go. 29 plus 37 is 66 over 12, which is 5.5. Or that reduces down to 11 halves. This one, x equals 29 minus 37 would be negative 8 over 12, which is negative, negative 2/3. 0.6 repeating would be negative 2/3. And then they want the product of these two. Well, if I take 11 halves times negative 2/3, those cancel and I get negative 11/3 is my product. As a decimal, it would be negative 3.6 repeating. Okay? And we are done with day 5. So I will see you next time for day 6.